Hello and welcome to Algebra 2 Lesson 66. In this lesson, we're going to continue to learn about parabolas. So in the last lesson, we covered some basic topics that come up when working with parabolas. In this lesson, we're just going to go a little bit further and expand on what we know. So the first topic we're going to talk about today would be how to find the vertex when our function is in standard form. So we see we have f of x is equal to ax squared plus bx plus c. And of course here a does not equal 0. So what's the vertex here? And in case you didn't watch the last lesson, what is a vertex in general? So with a parabola, with a standard parabola, a U shape that opens up, we know that the vertex is the lowest point on that graph. So in terms of the y location or the y value, on that coordinate plane, it is as small as it's going to get. Now, if you have the other scenario, if you have a parabola that opens down, so an upside down U is what that looks like, in that case, the vertex is the highest point. So in terms of the y value, it's as high as it's going to get. But either way, we use the same formula to obtain the vertex. Now, in the last lesson, I talked to you about the vertex form. So vertex form looks like this. It's f of x is equal to, you have a times the quantity x minus h, this is squared, and then plus k. So the reason we call this vertex form is that I can look at this function in this form, and I can immediately tell you what the vertex is. So the vertex here, the vertex will occur at the point h, comma, k, meaning whatever's here for h will be plugged in for the x coordinate, and whatever's here for k will be plugged in for the y coordinate. Now, before we go any further, let's think about why the vertex occurs at the point h, comma, k. Although you would use the same thought process either way, I want you to think about the fact that if you had an upward-facing parabola, so a standard U shape, your vertex is going to occur at the lowest possible point. So the y value is as small as it's going to be. So just for a second, replace f of x with y so we can get past that mental roadblock. And I just want you to think about what you could plug in for x to make y as small as it could be. Well, because we have this squared right here, no matter what I plug in for x, I subtract away something for h. When I square that, it's going to either be 0 or positive, right? If it turns out to be negative when I square it, it's positive. If it turns out to be positive when I square it, it's still positive. If it's 0 and I square it, I get 0. So the best I can do at making this small is to plug in an h, right? Because h minus h would give me 0. So this guy right here, once I square 0 would be 0. I multiply it by a, I still have 0. So this is knocked out and I'm just left with k. So that's why your vertex occurs at the point h, comma, k. So now, once we know that, let's think about how we could take a function in standard form, like f of x equals ax squared plus bx plus c, and transform it into vertex form. Well, what we're going to do is we're going to use that method known as completing the square. And most of you remember this from when we solved quadratic equations. We saw that we had to start out by learning the square root property. Then we learned how to complete the square. And then we found a shortcut known as the quadratic formula. It's going to be the same thing here. We're going to complete the square. Then we're going to see a shortcut known as the vertex formula. Okay, so let's jump in and look at an example. So let's say we see f of x equals x squared minus 9x plus 7. And your question here is to find out what is the vertex. So in order to do this, we want to put it in vertex form. So let's just write that form first. So this is f of x is equal to a times the quantity x minus h squared plus k. All right. So if you remember from completing the square, we start out by moving all the variable terms to one side and all the numbers on the other side. In this particular case, we're not going to do that. We want to just keep f of x on one side of the equation by itself. So we're not really going to mess with the left side at all. We're just going to do everything to the right side. But I'm still going to group the variable terms together. So I'm going to say x squared minus 9x. I'm just going to put some parentheses around it to say this is grouped together. And then we have this plus 7. Now, to complete the square, you look at your coefficient for the variable raised to the first power. In this case, that's going to be -9. So what do? You cut it in half, meaning you multiply by a half, and then you square it. So I would have -9 multiplied by a half, and then the result of this is going to be squared. So this would be -9/2 squared, which would be 81/4. Now, what does this do, this 81/4? Let me just jog your memory here. So let me erase this real quick, and I'm just going to put this value off to the side for a minute. So 81/4. The 81/4 is added right here. That is the constant that makes that trinomial into a perfect square trinomial. So remember, a perfect square trinomial is able to be factored into a binomial squared. That's what we got to get this guy right here. We want a binomial squared. So let's just go ahead and do that. So we would have f of x is equal to, we'd have the quantity x squared minus 9x, and then this guy right here is what I'm adding. So plus 81/4. So now I've got my perfect square trinomial. But there's a problem. I can't just go around adding things to equations, right? It's got to be balanced. Normally, if we add something to one side, we've got to add it to the other. But in this case, I told you we're not going to mess with the left side of this equation. So what we're going to do is we're just going to subtract it away outside the parentheses. So minus 81/4, and then I have my plus 7. So this right here is all together. That's my perfect square trinomial. That's what I'm going to factor into a binomial squared. And then this part right here, we can basically say this is together. So let's scroll down and get some room going, and we'll see what we get. So we have f of x is equal to, most of you remember from special products how to factor a perfect square trinomial. You know that this would be x. You have a minus here, so you get a minus here. And then you can always take this last term right here and take the square root of it. And so the square root of 81 is 9. The square root of 4 is 2. So you get x minus 9/2. That quantity is squared. And again, if you don't believe that that factors into that, pause the video, do FOIL, you'll get this back. Then we'll have minus 81/4 and then plus 7. Now, I want to combine these two. So I want to get a common denominator going, so I'll multiply this by 4/4. 7 times 4 is 28, so you would have 28/4 there. And then now it's just a matter of adding -81 and 28. So if we do that, we get -53. So we'll say that we have f of x is equal to the quantity x minus 9/2 squared minus 53/4. Okay, so let's scroll down. And I want to write the vertex form one more time. So we have f of x is equal to a times the quantity x minus h squared plus k. The vertex occurs at the point h comma k. Here's where you have to be ultra careful. You do have a minus sign here and here. So whatever occurs after that minus sign, in this case that's 9/2, is going to be your h. That's going to be your x coordinate for that ordered pair. So the vertex occurs at the point, you'll have 9/2, but then you have a plus sign here, but a minus sign here. So you've got to be very careful. Go ahead and translate this into plus a -53/4, so you don't make a mistake. And so -53/4 represents k, so that will be your y value. So -53/4. So the vertex for this function is going to occur at the point 9/2, comma -53/4. All right, let's try another one now. So we have f of x is equal to x squared plus 3x minus 10. And again, I want to put this in vertex form. So for vertex form, it's f of x is equal to a times the quantity x minus h. This is squared, then plus k. Now the vertex will occur at the point h comma k. All right, so let's go ahead and take this guy. We have f of x is equal to x squared plus 3x minus 10. Again, I'm going to group these variable terms together. Normally, I would move negative 10 over to the other side by adding 10 to both sides of the equation. But again, if you're doing this, you want f of x by itself, so I'm just going to leave it alone. I want to add 1/2 of this coefficient right here, which is 3, squared. So 1/2 times 3 squared. That would be 3/2 squared, which would be 9/4. So I'm going to add 9/4 inside those parentheses. But again, I can't just do that. I can't just go around just adding things to equations. I've got to make it balanced. So I'm going to subtract 9/4 away from the same side of the equation, because 9/4 minus 9/4 would be 0. Okay, so now that that's done, this can be factored into a binomial squared. So we would have f of x is equal to, this would factor into x plus 3/2, that quantity squared. And then you'd have your minus 10 minus 9/4. Of course, I'd want to get a common denominator going. So let's put this as plus negative 10. We'll multiply this by 4 over 4. So you'd have negative 40/4. So negative 40/4 minus 9/4. So you'd end up with minus 49/4. So minus 49/4. So we have this in vertex form. But again, you have to be very careful. This is a minus here. This is a plus here. So if you just go through and say, okay, my vertex will occur at 3/2, 49/4, you will be wrong. The signs just won't be correct. So I want to erase this. I don't want to match this up with this. I can make a plus into minus a negative, and I can make a minus into plus a negative. So now it matches exactly, and we'll see that h is negative 3/2. So I just put a negative out in front here. Let me kind of make that a little better. So negative 3/2. And k, okay, k is going to be negative 49/4. So negative 49/4. So the vertex here occurs at negative 3/2, negative 49/4. All right, let's take a look at one more of these, and then I will show you how to derive the vertex formula. And from that, you will find a very, very easy method to find the vertex when your function is in standard form. So we have f of x equals 3x squared plus 5x plus 7. So the one problem here is that we have this 3. That's the coefficient for x squared. You will recall when we complete the square, we say that we want the coefficient of the squared variable to be 1. Right? You'll recall that step from when we completed the square when we're solving quadratic equations. So what we would do is we would divide the whole equation by, in this case, it would be 3. But we're not going to do that here. What we're going to do here is we're just going to factor it out from this grouping here. So in other words, if this is a group, I could factor a 3 out from that group. And if I factored a 3 out from 3x squared, I would have x squared. If I factored a 3 out from 5x, what would I have? 5x divided by 3 is what I'm looking for there, because 3 times 5x over 3, the 3's would cancel and I'd be right back to 5x. Then I'd put plus 7, and I can kind of move that out here. And I can go through the process now of just completing the square. So I want to take 1/2 of my coefficient for the variable raised to the first power and square it. So 5/3 times 1/2 squared. So this would be 5/6 squared. 5 squared is 25. 6 squared is 36. So now I want to add 25 over 36 to this side right here. Here's where you have to be careful, though. So I'm going to show you a common mistake. So plus 25 over 36, close the parentheses, minus 25 over 36. So students will do that, and then they'll continue to solve the problem. This is going to give you the wrong answer. Why do you think that's the case, in case you haven't seen it already? Well, you're multiplying 3 by this guy right here. So I'm not really adding 25 over 36. I'm multiplying 3 by 25 over 36. So I've got to do the same thing to this guy. Otherwise, I'm not balancing the equation. So what I usually do is I'll expand my parentheses out here, and then I'll do another step. So I'll do f of x is equal to 3 times the quantity. So I'll tighten my parentheses down. I'll say x squared plus 5/3 x plus 25 over 36. I'll close my parentheses there, but this allows me to remember that 3 is going to be multiplied by this. So I'll put plus negative 25 over 36 multiplied by 3. Now I have added and subtracted the same value to that right side of the equation. So I'm good to go. So then plus 7. Okay, so let's scroll down, get a little room going. All right, so we're going to have f of x is equal to 3 times, if I factor this guy, I'm going to have x plus 5/6 in this quantity squared. Then over here, I have negative 25 times 3. That's negative 75. So you'd have negative 75. And this would be plus 7. So I would get a common denominator going. And to do that, I'd multiply this by 36 over 36. And so 7 times 36 is 252. So you would have 252 minus 75, which is 177. So you could say this is plus 177 over 36. Now I can reduce this fraction. 177 is divisible by 3. 1 plus 7 is 8. 8 plus 7 is 15. And so is 36, right? 3 plus 6 is 9. If I divide 177 by 3, I'd get 59. So this is 59. And then 36 divided by 3 is obviously 12. Okay, so I have this in vertex form. But again, I've got to match everything up to where I don't make a sign mistake. So the vertex form, again, it's f of x is equal to a times the quantity x minus h, and this is squared, and then plus k. This is a minus. Right now, this is a plus. So I've got to change this to minus a negative so that this value right here can be plugged in for h. Then I have plus k. So in this case, I have plus 59/12. That's okay, right? This will just match up completely. That'll be my value for k. So the vertex will occur at negative 5/6. That's my h here. And so that's going to be my x value, comma, k is 59/12. So 59/12 will be my y value. So the vertex occurs at the point, negative 5/6, comma, 59/12. All right, so now what we're going to do is we're going to take a generic quadratic function in standard form, and we are going to convert it into vertex form. And from this, we're going to derive something known as the vertex formula. This is basically the same thought process as we use when we derive the quadratic formula, right? We have these parameters a, b, and c that we can just easily grab and plug into the formula that we have, and then we can solve things very, very quickly. So if I was to have this guy right here, and again, I want this in the format of f of x is equal to a times the quantity x minus h squared plus k. The first thing I would do is I would factor out the a from these first two terms right here. So f of x is equal to, bring the a outside, I would have x squared plus, to factor an a out from here, I would basically divide b times x by a. So in other words, this would be bx over a. And again, if a multiplied by bx over a, the a's would cancel, be back to bx. So then we can close this, and then we'll have plus c. Okay, so now that we've done that, we want to complete the square. We want to take this guy right here and just make it into a perfect square trinomial so that we can factor it into a binomial square. Okay, that's the goal. So let's scroll down, get a little room going. All right, so I want to take my coefficient for the x to the first power variable. In this case, that's going to be b over a. So b over a. And I want to cut it in half, so multiply by half. And then I want to square the result. So this would be b over 2a. So this would be b over 2a. And this would be squared, giving me b squared over 4, right? 2 squared is 4, times a squared. Okay, so now let me erase this, and let me kind of scooch this up. Again, we have to be careful. If I just shove this in right here, remember, a is going to be multiplying by that, so I can't just balance it outside of the parentheses. Okay, so what I want to do to remind myself, I'll have f of x is equal to a times the quantity x squared plus b over ax plus b squared over 4a squared. Then I'm going to put minus b squared over 4a squared. This is all inside the parentheses, then I'll close the parentheses. Okay. Right now, the way it's set up, a would multiply all of these. So I am adding and subtracting the same value to the same side of the equation, and so I'm basically adding 0. Right? I'm not changing it, it's balanced. Okay? That's what you have to do. If you make the mistake and you do this, and you forget to multiply by a, you're going to get the wrong answer. So make sure you put your parentheses here as a reminder, and then we'll put plus c here. Now, in the next step, we'll tighten this down, but the way we're going to do it, we're going to say f of x is equal to a times the quantity x squared plus b over ax plus b squared over 4a squared. I'll close the parentheses because this is a perfect square trinomial, but then I'm going to remember that a is going to need to be multiplied by this negative b squared over 4a squared. So plus, we'll have a multiplied by negative b squared over 4a squared. Scroll down and get some room going. And then, of course, we have plus c. Okay, so now we have a perfect square trinomial here. So I'm going to factor that guy into a binomial squared. So f of x is equal to a times the quantity. This would be x plus square root of b squared is b. Square root of 4a squared is 2a. And then this quantity is squared, then plus. Over here, I just need to do some simplification. So this would cancel with one of these. I'd have negative b squared over 4a. Now I can flip this around and say I have c minus b squared over 4a. And then I can get a common denominator by multiplying this by 4a over 4a. And what's going to end up happening is I have plus 4ac minus b squared. So 4ac minus b squared over the common denominator of 4a. Now, there's one other thing we want to do here. Remember, when I show you vertex form, it's f of x is equal to a times the quantity x minus h squared plus k. So here, k is this guy right here. So that's going to be the y coordinate when you're talking about your vertex. And then h, there's a problem getting it straight from this because you have a plus sign here, and here you have a minus. So we want to just make one minor change here and put this as minus a negative b over 2a. And now this guy right here will be my h. That's what's going to get plugged in for my x location when I'm building the vertex. But it's going to get even simpler than that. So let's scroll down just a little bit. And let's write our vertex. So this is the vertex formula. And you definitely want to write this down because it's going to save you a lot of time. So the vertex formula, you take a quadratic function in standard form, and you know what a, b, and c are, and you can plug into this formula and find out the vertex. So the vertex will occur at the point negative b over 2a, and that came from right here. Again, normally it's h. H here is this, negative b over 2a. Then, comma, you could plug in 4ac minus b squared over 4a. But there's an easier solution. I want you to think about the fact that if I plugged in a negative b over 2a for x, what would happen there? Well, you would get 0. And again, this would cross itself out. You'd just be left with this. This is what would be left. So instead of writing all this, all I want to say is that I want to plug this in for x. How do we do that with function notation? Well, we say f of whatever we want to plug in for x. So in this case, that's negative b over 2a. And that's going to be my value for y, or you could say your value for k, however you want to think about this. So hopefully that makes sense for you. Again, the vertex formula, the vertex occurs at the point negative b over 2a. This is what's going to be the x location on the coordinate plane. And then f of negative b over 2a, this is your y location on the coordinate plane. And again, just so you're not confused, The way we got that is if I plugged in a negative b over 2a in for x, this part right here would go away. It would basically be 0, and I would be left with my value for k, which in this case is 4ac minus b squared all over 4a. So that's why we put that there. It's just easier than writing 4ac minus b squared over 4a. If you want to put that there, you can. It's the same answer either way. Okay, so let's try a few out. This is very, very simple. So we have f of x is equal to 8x squared plus 16x minus 7. So we have a quadratic function in standard form. If you get one that's not in standard form, you need to put it in standard form. Okay, so if you see that trick question on a test, make sure it's in standard form. So what's my a? That's the coefficient for the squared variable. What's my b? That's the coefficient for the variable to the first power. And for the formula I gave you, you don't need c, but just in case you want it, c is going to be -7. That's the constant. So a is 8, b is 16, c is -7. Okay? So I want to find the vertex. So the vertex occurs at negative b over 2a, comma, f of negative b over 2a. Okay, so what's negative b? B here is 16, so negative 16 over 2a. A is 8, so 2 times 8 is 16. Negative 16 over 16 is -1. So the vertex occurs at -1, comma. Then what I want to do, I want f of negative b over 2a. We know negative b over 2a is -1, so we want f of -1. And this is equal to 8 times, you'd have -1 squared plus 16 times -1, and then -7. So if we had -1 squared, that would be 1. So this is basically 8 times 1, or 8. And then if you had 16 times -1, that's -16. So this would be -16, and then -7. So 8 minus 16 is -8. Then -8 minus 7 is -15. So this would be -15 here. So f of -1 is -15. So just that quickly, we found our vertex. No messy completing the square. No long, lengthy process. Pretty straightforward. So all you have to do is kind of write this down and understand how to find a, b, and c, which is very, very simple. And you will have your vertex right away. So once again, the vertex here is at the point -1, comma, -15. All right, let's try another one. So we have f of x equals 3x squared minus 4x plus 6. So again, the vertex formula, the vertex will occur at -b over 2a, comma, f of -b over 2a. Okay, so for -b over 2a, this is a, this is b, and this is c. So -b. B is -4. So the negative of -4 is +4 over 2a. A is 3. 2 times 3 is 6. So we'd have 4, 6. We could reduce that to 2/3. So the vertex will occur. You'd have 2/3 for the x location, comma. Then you would have f of 2/3. F of 2/3, right? It's f of -b over 2a. We found that -b over 2a was 2/3, so it's f of 2/3. So this would be equal to 3 times 2/3 squared minus 4 times 2/3 plus 6. If I squared 2/3, I would get 4/9. So this would be 4/9. And then 3 times 4/9, this would cancel with this and leave me with a 3 down here. So this would be 4/3. So I'd have 4/3 here. Then -4 times 2/3. You think about that as -8/3. So we'll say -8/3. Then you have plus 6. 6, if I multiply by 3 over 3 to get a common denominator, that would be plus 18/3. And then I could say 4 minus 8 is -4. -4 plus 18 is 14. So this would end up being 14/3. So f of 2/3 equals 14/3. And that's going to be my location for y for that ordered pair. So the vertex occurs at the point 2/3, comma, 14/3. All right, so now let's talk about the discriminant. So you'll recall when we solved quadratic equations, we saw ax squared plus bx plus c equals 0. And we derived the quadratic formula. So if we want to solve something in this form, we can say that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, what we're going to focus on here is this part under the square root symbol. This is known as the discriminant. Now, the discriminant gives us information about the number of x-intercepts we're going to get. And we'll cover that in a second. But for right now, we just want to say if b squared minus 4ac is greater than 0, we're going to have two real solutions. And therefore, you'll see in a second, two x-intercepts. If b squared minus 4ac is equal to 0, you're going to have one solution and therefore one x-intercept. You might say, well, why do you only have one solution here? If this guy was 0, the square root of 0 is 0. So you have plus or minus 0, that's basically nothing, right? You can get rid of that. And you just have negative b over 2a, that's your solution. The last scenario is that b squared minus 4ac is less than 0. So when we see this, we don't have a real solution. Remember, we covered what to do in this case. You use complex numbers, right? We bring in our imaginary unit I. But when this occurs, we will not have an x-intercept. All right, so here we have f of x equals ax squared plus bx plus c. And if we allow f of x or y, okay, think about this as y for a minute, to be 0, what are we saying? Remember when we talked about linear equations? When y was 0 and we solved for x, we were finding the x-intercept, right? Because it's the point where y is 0, so we are going to cross the x-axis. So if there are two solutions, as in b squared minus 4ac is greater than 0, we're going to have two x-intercepts, or two spots where that graph is going to cross the x-axis when y is equal to 0. Then if b squared minus 4ac equals 0, one x-intercept. And then if b squared minus 4ac is less than 0, then no x-intercepts, right? So if you don't have a real solution, you will not find an x-intercept. So if we looked at this example, f of x equals 5x squared minus 3x plus 10, and we said how many x-intercepts will be here? Well, again, you just look at your discriminant. So that's b squared minus 4ac. A is 5, b is negative 3, c is 10. So what is b squared? Negative 3 squared is 9, minus 4 times a is 5, times c is 10. So just looking at that, I know that this is going to be less than 0. 4 times 5 is 20, 20 times 10 is 200. You would have 9 minus 200, which turns out to be negative 191, and negative 191 is less than 0. So again, if the part that's underneath the square root symbol is negative, you know you're not going to have a real solution. So when this is less than 0, there's no real solution, and so there's no x-intercepts. So 0 x-intercepts. All right, if we looked at another one, we have f of x equals negative 7x squared minus 2x plus 1. So again, we're looking to see how many x-intercepts we have. So this is my a, negative 7. This is my b, negative 2. And this is my c, 1. So the discriminant is b squared, so negative 2 squared, that's 4, minus 4 times a is negative 7, times c is 1. So you might as well say this is plus negative 4 to make it easy. Negative 4 times negative 7 is positive 28. 28 times 1 is still 28. So this is 28. And without even doing the addition, we know this is positive, and so we know that there are two real solutions, or two x-intercepts, right? 4 plus 28 will give me 32. So 2 x-intercepts. All right, so another thing to consider, if we're graphing a quadratic function, if a is greater than 0, the parabola is going to open up. If a is less than 0, the parabola is going to open down. So a, again, is the coefficient of the squared variable, okay? The coefficient of the squared variable. So if that's positive, you're going to have a U-shape. If it's negative, you're going to have an upside down U-shape. So two examples here. We have f of x equals negative 7x squared minus 3x plus 2. In this case, the negative 7 here tells me that this guy is going to open down, right? It's going to open down. For this one, f of x equals 3x squared minus 5x minus 2. The positive 3 tells me this guy is going to open up. All right, so if you wanted to graph a quadratic function, if your teacher made you do it, just as an exercise to see if you could, the first thing you would do is determine if the graph opens up or down. Again, look at the value for a. Is it positive, it opens up. Is it negative, it opens down. Then you want to locate the vertex. We have the vertex formula for that. That's pretty easy. So you want to plot the x-intercepts if you have them. Again, f of x or y will be equal to 0. So you're solving ax squared plus bx plus c equals 0. What we've been solving forever, right? We can use the quadratic formula for that. And then for the y-intercept, you want to find f of 0, okay? Remember, if I am plugging in for x in function notation, I just put what I want to plug in right there. So f of 0 means I'm going to plug in a 0 for x. And again, we know this from graphing linear equations. If I plug a 0 in for x, I'm finding the point where x is 0 and I'm crossing the y-axis. Okay, so that's going to give me my y-intercept. All right, then I want to plot additional points as needed. To graph a parabola, you only need 3 points, but again, you're not graphing a line, so the shape isn't always 100% clear. Again, that's why we use these graphing calculators and software to kind of do this for us so that it's accurate. Then lastly, you will sketch the graph. Okay, so let's give one of these a shot. I'm just going to do one, and then if you want to do some additional practice on that, that's fine. But again, I'm just going to tell you, as you move out of Algebra 2, you get into trigonometry and calculus and college algebra, most of the time, you're not going to hand draw things. You're going to be using your graphing calculator or some type of graphing software. All right, so the first thing is this guy right here, f of x equals negative x squared minus 6x minus 8. This is negative here, so I know it's going to open down. So opens down. So I know that. It's going to have this shape right here. All right, so the next piece of information, what is the vertex? So the vertex will occur where? Negative b over 2a, comma, f of negative b over 2a. And what is a and b? So this is a, that's negative 1, and b is negative 6. So the negative of negative 6 is 6 over 2 times negative 1, which is negative 2. So 6 over negative 2 is negative 3. So the vertex will occur at negative 3, comma. Now I want to plug a negative 3 in for x. So I'd have f of negative 3. This would equal negative, and then negative 3 squared, minus 6 times negative 3, then minus 8. Let's erase this. So negative 3 squared is 9. So I'd have the negative of 9, just negative 9. And then negative 6 times negative 3 is positive 18. So this would be plus 18. And then it would be minus 8. So minus 8. So negative 9 plus 18 is going to give me 9. 9 minus 8 is 1. So the vertex will occur at negative 3, comma 1. Okay. So now we want to figure out what our x-intercepts are. So we would set this equal to 0. So we would say this is 0. And I would just solve negative x squared minus 6x minus 8 equals 0. Again, I can use my quadratic formula for that. X is equal to negative b. B is negative 6, so the negative of negative 6 is 6. Plus or minus the square root of b squared. Negative 6 squared is 36. Minus 4 times a is negative 1. Times c is negative 8. This is all over 2a is negative 1. So 2 times negative 1 is negative 2. So I think about this as plus negative 4 to make it easy. Negative 4 times negative 1 is 4. 4 times negative 8 is negative 32. 36 minus 32 is 4. So you'd be taking the square root of 4, which is 2. So your two scenarios here is 6 plus 2 is 8. 8 over negative 2 is negative 4. And then your other scenario is 6 minus 2 is 4. 4 over negative 2 is negative 2. So those are x values, but remember the y value is going to be 0 in each case. So we would say that our x-intercepts will occur at negative 4 comma 0 and negative 2 comma 0. Okay. Now where's our y-intercept going to occur? To find that, we want f of 0, right? I want to plug in a 0 for x. So if this was 0 and this was 0, they'd basically be gone, right? I just have negative 8 there. So f of 0 is negative 8, so we would have an x value of 0 and a y value of negative 8. This is your y-intercept. Now, we might need additional points. Let's just go down to the graph and see what we're looking like. Let's start with the vertex. It's at negative 3, comma 1. So negative 3, so 3 units to the left, comma 1, 1 unit up. And then the next point we want, our x-intercepts, we have negative 4, comma 0 and negative 2, comma 0. So negative 4, comma 0 and negative 2, comma 0. So at this point, you have 3 points. You could sketch a parabola, so you could start there. But the problem is you really don't get a good representation of like where this thing is going to go, the angle and whatnot. So that's why you try to get some additional points so you get more information. I know my y-intercept occurs at 0, comma negative 8. So 0 for the x location, negative 8 for the y location. And then we can get one additional point going. Let's figure out where x would be if y was negative 8. So we know there's one place here at 0, comma negative 8, but what's the other place? So let's go and let's plug in a negative 8 for y, or for f of x, however you want to think about that. So negative 8 equals negative x squared minus 6x minus 8. So I would add 8 to each side of the equation. So this is gone, this is gone. So you have negative x squared minus 6x is equal to 0. I could factor a negative x out there. So negative x and then times the quantity. You would have an x plus 6 inside, and this equals 0. So one solution is that x equals 0. So we already have that with the y-intercept. X is 0, y is negative 8. We've got that. The other solution would come from this factor right here. If x plus 6 was equal to 0, if x plus 6 is equal to 0, subtract 6 away from each side of the equation, you say that x is equal to negative 6. So an additional point would occur when x is negative 6 and y is negative 8. Okay, this is an additional point. Okay, so negative 6, comma 8. So that's going to be right there. All right, so let's go ahead and attempt to graph this guy. Again, I'm not a good drawer, but I'll do my best. So, okay. So not the best drawing in the world, I realize that. But if you wanted to see an accurate representation of what this looks like, we can look at a computer-drawn graph for f of x equals negative x squared minus 6x minus 8. Now the scale is a little bit different. My y-axis didn't go that far down, but again, you can see how perfectly drawn this is. And that's what you're going to get when you graph these things with some software, a graphing calculator, your computer, maybe some app on your phone, whatever you have. That's much preferable to hand drawing. But again, if you need to hand draw it, at least you know the steps.